Can we see this okay when the page comes up, or do we need to turn the light off? Chidera! Could you turn the light off, please? Thank you. Right, let's start with 2a on page 38. My question is, what is the nth term for this sequence? So, I think this is it, isn't it? Yes. So what's the a here? Well, it's minus 9, because that's the one you start at. And the d, what's that? Minus 5, because you're minusing 5 each time. And the formula we had is un is a plus n minus 1 d, which is minus 9 plus n minus 1 times minus 5. So that is minus 9 minus 5n plus 5. Yeah. So that is minus 9 plus 5 is minus 4, isn't it? Minus 4 minus 5n. And that's the answer there for that one. So in a moment we'll have a look at Did I do 4a last time? Will I do something? What one did I give you for homework? I did the a's, did I? Yeah. So maybe I'll do, what one did I give you for homework? 4i, was it? Yeah, okay, I'll do 4i next then. Yep, 4i. So I tell you that the 8th term is minus 46, and the 19th term is minus 112. So this means a plus 7d equals minus 46, and this one is a, you know what, I'll write underneath, a plus 18d. Yeah? Yeah. Add or subtract? Subtract. A minus a, gone. 18d minus 7d, 11d. Yeah? That's from the formula. It's a plus n minus 1d, and the n here is 8. So n minus 1 is 7 then. Yeah. Likewise for the 19th term, that's 18d. Yeah. Because of this. Right. What is minus 112 plus 46? What's that, please? That's 50, 60, minus 66, is it? So that means d is minus 6. Yeah. And if I put that in there, you end up getting a is minus 4, is it? A will be minus 46 minus 7d, which is minus 46 plus 42. So a is minus 4. Is that what we said? Yeah. Okay, we'll do 7f next. Yep, we got that? Yep, okay. Next one now is 7f, we said. So minus 1 plus 0 plus 1 plus dot 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 24. Okay, so the A is minus 1 and the D is 1. And we need to figure out how many terms there are. So we do that by saying UN equals 24, A plus n minus 1D is 24, n minus 1 times 1 is 25, n minus 1 is 25, n is 26. So now that I know my n, I can finally work out what I wanted all along, which was the S26, the sum. So that formula is n over 2, 2a plus n minus 1 times d, which is 1. So that would be 13 times 23. And what's that now? 291. 291? 299? Okay. Yeah. Okay, and then lastly on this page we'll do 8f. Okay, shall we look now at 8f? So in 8f, I tell you, the sum of the first 12 numbers is 630, and the 27th number is 237. So what this guy means here, yeah. Oh, to the last thing? Problem? 299, yeah. Is okay? Yep. Right, so this guy, that says n over 2, 2a plus n minus 1d equals 630. And this one here says a plus n minus 1d equals 237. So 12 over 2 is obviously 6. And this is still the same. You can divide 630 by 6, can't you? Or can you? 6 into 6 once. Is it 105? Yeah. 2a plus 11d equals 105. Now what I'll do is I'll multiply this equation by 2. So now I have 2a plus 54d. Where am I stuck? 54d, isn't it? Oh, sorry, 52d. 52d equals 474. No, yeah, 474. Okay, so look, we have two equations. Let's solve them. So the first one is 2a plus 52d equals 474, and the second one is 2a plus 11d equals 105. So if I subtract, I'll get 41d equals, that guy goes, that becomes a 17, that becomes a 16, what's that, a 9, a 6, 469, is it? No, what am I saying? 369, sorry. Divided by 41 is 9. Okay, so we have the D is 9, yeah? And now how can we get the A? If we put it back into this one, I think. So we get A plus 26 times 9 equals 237. So A is 237 minus, whatever 26 times 9 is. So what do we get for the A now? 3. Okay, so there's my A and that's my D. What page? Yeah. Yep. Yep. Okay. Do we all have that? Yeah. Okay. Oh, is that a no or a yes?
Well, the second one, number 5 and 7 equation, where is the, where is the 27 over here? Near the end of the 2.
It's U27, not S27.
Oh. Yeah.
Next. So, page 40 now. Page 40. Question 8A, did you say? Yep. Okay, so the ninth term, the ninth term is minus 6561, and the sum of the first two terms is 2. Yep. So this is simply saying A or 8 equals minus 6561, and this one is saying A 1 minus or squared over 1 minus or equals 2. Okay, Angela, what did you try next?
I tried to make the, I multiplied everything by A in the second equation.
Multiplied in the A?
Yeah.
Nah, don't think so. What you could do next is you could simplify this.
But yeah, that's what I was trying to do.
Yeah, well let me show you how to simplify it, okay? So what you do is you just divide 1 minus or into 1 minus or squared. And you'll get 1 times that is 1 minus or. Then you subtract, and you get or minus or squared. So the next one here has to be plus or, and you get or minus or squared, and you get 0. So this guy can be simplified. So now we have A or 8 equals minus 6561, and here it's A times 1 plus or equals 2. Now this actually shouldn't surprise you, because if you really think about it, what is this equal to? It's equal to A plus A or, which is the sum of the first two terms anyways.
Yeah.
So it's hardly surprising. Okay, well, that's a little bit better. So, now what? So what do you think? Yeah, what's next? What would we do next? How would we solve these two equations? Any ideas, anybody?
Take the powers of all C.
Not possible here. Any ideas? What method could we use? Could we use elimination? No. Substitution, okay. So what do I make the subject? And which equation?
Make A the subject.
In which one? First or second?
Second one.
In this one?
Yeah.
Yeah. Or actually, or in this one. It doesn't really matter. So if you were to say,
that one would be better because you would get R into 8.
you know what? I'll do both. So then this one here, I get minus 6561 over or 8.
Yeah.
And now what can I do?
Now, put it in.
Yeah. What's the verb?
Substitute.
No, equate. Minus 6561 over or 8 equals 2 over 1 plus r. Okay.
And now, cross multiply.
Yes. Minus 6561 over 2 equals or 8 over 1 plus or. Now what to do next?
Can you no.
Any ideas? It's tricky. This equation is the hardest equation.
But isn't the R8 divisible by 1 plus?
No, it's not. Any ideas, anybody? How to solve this? No ideas? Want to see? Yeah. Yeah. Okay, is that obviously I just put the minus at the bottom.
Why?
Now, y will become really clear in the next line. So, you need to watch carefully what's about to happen. Okay. This, well, actually I won't rewrite like that. I'm just going to rewrite this number here. So, minus 2 is the same thing as 1 plus what number? Minus 3. 1 plus minus 3 is minus 2. And 6,561 is obviously minus 3 to the power of 8.
Yes,
obviously.
Very
Yes. So, by writing this like this, I think it becomes clear what the or is. What's the or? Minus 3. Yeah. Tricky.
Is this going to be
No.
So for the big formative assessment, do we, like, is it up till the function that you're going to teach us till the 21st of
I think the last thing I have in the exam, like the last couple of questions, I have a couple of questions on an arithmetic and geometric. So I give you a sequence and I ask you for the sum in the arithmetic, and then in the geometric question I give you a sequence and I ask you for the sum.
No, what I meant is, this is where, in what portion will we have to...
Yeah, up to that.
Up to that.
The last thing you'll have to... The test is in order. It's a little bit from everything up to arithmetic and geometric. So the last thing on the test, or the last question I wrote, I should say, because the questions are not in order. The last question I wrote is an arithmetic and a geometric question. I think just simply, what is the sum and what is the sum? So basically to page 40. I can zoom out a bit, yeah? Now, who can answer this for me? Why did I bring the minus to the denominator here to here?
So that we can find the, because when it is raised to 8.
Yeah, that's the key. That's the key. When it's raised to power 8, it can only be a positive number. If I'm trying to match the left and the right, I need to have the sign in the right place. The sign could never be in the top if you're trying to match the fraction. It has to be in the bottom because of this power here.
Wait, find A. Where is it?
Oh, okay. I didn't get the A yet. Then just put the
Yeah.
just put it back into say this guy.
A is what?
So A, yeah, would be 2 over 1 plus or, which is 1 minus 3, which is minus 2. So the A is 1.
I'll just put it into A. A are raised to 8.
Yeah.
6 is.
Oh, yeah, or 8 is 6, 5, 6, 1. So, yeah, minus 1 then. Oh, sorry, minus 1, yeah. Yeah. Now, what's next? Hey, I forgot your name. Ah, you're a little bit early. You're in here half an hour, yeah? Yeah, of course, yeah, you can leave your stuff there. Right, what are we looking for next now? Which page next?
Binomial theorem.
Yeah, what page is that? Huh? 32. Right, which question?
Something 4 or 5.
Yeah, which one did I give you for homework in number 4? On page 32.
First one that.
Did I give you 4A? Okay, I'll do 4A then. Yeah. Huh? Oh, yeah, that's fine, yeah. Okay. Px plus q power 6 is 1 plus 6x plus 15x squared plus dot 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 dot. Right, let's expand here. So if I expand on the left, I'll get 6c0 p6 plus 6c1 no, I did something wrong there, sorry. 6c0 px0 q6 plus 6c1 px1 q5 plus 6c2 px squared q4 dot 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 equals. Right, 6c0 is 1, px0 is 1, so you have q6. 6c1 is 6, so that's 6 pq5x plus, what's 6c2? 15? 6c2, please?
Wait, why did you start with the q to the power of 6 and the px to the power of
Because I start.
0, but not the other way?
Which way are the x's moving on the right?
Ascending.
Yeah, so likewise on the left. What's it? 62? Huh? It is 15. 15 p squared q4x squared dot 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 equals 1 plus 6x plus 15x squared dot dot dot. Okay, let's compare. So this q power 6 has to be the same as 1. And this 6 6pq5 has to be the same as 6. So if I look at the first equation, I get q6 equals 1. So therefore, what does q equal? What's q here? If q power 6 is 1, what's q?
1.
Or minus 1.
Oh.
So we have 15 p squared q4 has to equal 6. Now this q4 is 1, so that's gone. Oh sorry, I wrote the wrong thing down, apologies. I meant to write down 6pq5 should equal 6. I'm looking at this one now and this one. Okay, so you get then pq5 equals 1. But p is plus or minus 1. So then you get q5 is plus or minus 1. So what's q? Q is also plus or minus 1. Now can we decide which it is? Yes, we can, because in the question I tell you P and Q are positive. So the answer is P equals 1, Q equals 1.
If there is quantity, will you explain page 40, question number 10? The exponential thing.
Yeah, we can have a look at that. But it only makes sense if you've studied the E before. Well then perhaps it would make more sense to do that after lesson on the page 46. Why don't you make a note on page 46 to ask me about the question on page 40 then? Okay. What's next now?
The way you pair up the values from one side to the other side is whatever comes first and then the first comes first, second comes second.
Essentially, yeah. On which page? 54. 54. Yeah. Which sequence do you want? Number 6. Oh, number 6. Yeah, that's right. Very good. Because I wanted to, somebody was asking me for that this week or last week. I said I wanted to do it in class because I have the computer program. So let me just.
They are the same equation basically. So
Yeah, it's interesting, isn't it? Hey, Mark. That's still 6. No, we've moved on to 7 now this week. Yeah, we might get up to 10 by Christmas.
They're going so fast for you,
Yeah.
so do we just plot those numbers over there?
Yeah, and I'll show you what the plot should look like. But first, Michelle, the first thing we'll do is we'll just get a few terms, okay? So, whoops. I'll get the first 4 terms, okay? So if I put in n is 1, I have 1 over 1 squared, which is 1. And if I put in n is 2, I get 1 over 2 squared, which is a quarter. And 3, I get a ninth. And 4, I get 1 over 16. Yes, actually, no. I was talking to a bear about this last week. Your education system, where were you educated? Ah, would it have a British influence?
Yes.
Ah, yes, okay. So, you'll have to change your vocabulary because here, what does this word mean to you? So if I said,
Yeah, I noticed that.
yeah,
You say for 4 into 2.
yeah,
4 times 2.
yeah, it's exactly the opposite to how you say it, yes. Yeah, so into means divide. Yes, okay. So you know that it's opposite here. Alright, you'll need to keep that in mind now, okay?
Into's divide?
Huh? Into's divide. Not multiply here.
Into is
Yeah.
if you did 4 into 2, you know, where do I divide to?
If I said 4 into 2, that's this. Yeah?
Divided by 4.
If I said 4 by 2, that's this. Yeah. Yeah. So you need to be careful with that when you're talking to people. Okay, anyway, what do we notice that's happening to this sequence? What does it appear to be doing? Would you say it's convergent or divergent? What would you say? What do you think? No, tell me, what did you say? What did she say? I didn't hear her.
It's convergent?
Yeah, it's convergent because it's getting smaller. It's approaching what number, do you think?
0?
Yeah, it's approaching 0. Okay. Now let's have a look at the next sequence. So we have Vn plus 1 equals Vn over 1 plus root Vn squared. So I tell you to start at 1. So the next term would be 1 over 1 plus root 1 squared, which is 1 over 4. Okay, and then the next one, V3, would be 1 over 1 plus root 1 over 4 squared. And actually, when you put this in the calculator, you get 1 over 9. And I think we see what's happening here is actually the same sequence.
Isn't it 1 over 4 by 1 plus 1, root 1?
Oh, sorry, this top is a Vn, isn't it? So I should have had a 1 over 4 on the top here. Yeah? Yeah?
Yes.
So if you put that in the calculator, you get 1 over 9. And then the last one, V4, will be 1 over 9, 1 plus root 1 over 9 squared, and that works out to be 1 over 16.
Yes.
So the reason I did this question, I wanted to show you that you can actually get the same sequence from two totally different looking formulas. Right? Now, how do you plot a sequence? So what's the appropriate graph for a sequence? Does anybody know? Like, if I was to write down, let's see, what did I say? 1 over 4, 1 over 9. What the heck? 1 over 4, 1 over 9. Why does it think it's a date? What is 1 over 9? It's 0.1111. Yeah, okay. And then 1 over 16? There, no, I have it there. Okay. What graph should I use to plot these? You know, in Excel? Scatter, XY, pi, like what's it? Yeah, no, it's not actually. No. Well, you have a Y, you know, kind of. The best graph to use here, where's it gone? Chart. Is this type. Yeah. So yeah, the way the title is sequence of UN, and the x-axis is the n, and the y-axis is the value UN. Now let me just. So that's what the graph would look like. Now, if I'm being very picky about it, I kind of would prefer if the bars were touching. How do I change that here?
You make it an
It's not quite a histogram, but I want it to look like one. How do I edit this?
So that's grade 9.
Ska-
Why, or because of the sequence, is that why you want to capture?
It's not the end of the world if it doesn't, but I would much prefer it if it did. I thought there was some way you could format this, no? It's not quite doing it the way I want. Really, those bars should be touching, anyway. So, why do you think a bar is the most appropriate graph to use? Yeah, but an XY would do that as well. Anybody know? No? Like, why did I do this and not this? So, I could have drawn my graph like this, which I did, or I could have done it like this. I could have plotted the points and drawn that. So that versus that. Why is the bar better here? Oh, come on, someone must have an idea. That's the key thing, it's discrete. That's the key thing, discrete. So this one here, you're allowed to use it because if there's 1 and there's 2, you can legitimately be between 1 and 2. Okay? Whereas here, if that's 1 and that's 2, you can't be between 1 and 2. You can either be at a height which corresponds to 1 or a height that corresponds to 2. But you can't be at a height that corresponds to 1.5 because it's a sequence, yeah? So this is why the bar chart is more appropriate of a graph for a sequence. Yeah?
Are we going to do histogram sequence?
Yeah. I think in semester 2. Semester 2. Yeah. Did you say statistics? It sounded like... Oh, right, okay.
Yeah,
I thought you had statistics. Yes, no, that's what I was wondering. Do you know in English what the expression Freudian slip means? Have you heard this? Yeah, okay, alright. I didn't know if you were secretly revealing your feelings towards it. Okay, did you write this down? Yeah. There's one question I would like to do with you at the end of that page as well. Yes, Angela? No, it's okay?
I have a question.
Yeah.
Do you mind reminding me exactly like what's the rule for stating whether it's divergent or...
It's not really a rule. You have to calculate like 5 or 6 terms and judge for yourself what you think the sequence is doing. So if it appears to be approaching a finite number, we call that convergent. If it appears to be moving away up to infinity, we call it divergent. And periodic is obvious because it's looping. It's repeating. You know?
So if it's a positive number and it's decreasing, then it's obviously approaching 0.
If it's a positive number, decreasing, yeah, and it's always positive, then it's approaching 0 probably.
It's a negative number.
Yeah.
If in the exam, if they ask what type of a sequence should I say, like convergent or what?
Nah, if they ask you for the type, they don't also at the same time want the limit. Yeah. Okay, did you write that down? I'm going to just give you a minute to try something for me. At the end of page 34, I have this sequence. Fn equals Fn minus 1 plus Fn minus 2, which basically means the term that you want is equal to the last term plus the one before last. Yeah. Huh? Yeah, it's the last one on page 34. So F1 I tell you is 1, and F1 I tell you is 0, is it?
Yeah.
And F2 I tell you is 1. So I want you to calculate F3 and F4 and so on. So I'm looking for the first 10 numbers here. So I've given you 0 and 1 so far. So I'll just give you a minute to try that now. Whoops, sorry. Switched.
particle problem, will this be in the exam as well? Yes.
The practical ones? Nah. Just getting something here for you.
If like in another question here, it says if you have S2 in page 40 for the GP,
Yeah.
S2 is equal to something, S2 is equal to something else. So if I still keep it as, if I directly just put A to 1 plus R.
That's okay. Yeah, that's good. Right. Did you get the next terms? Guys, what's the next number here? 1. Next. 2. Next.
3, 5,
8.
13, 21,
And so on. Okay. Now, I want to give you an interesting biology example to this sequence, okay? I'll scroll down a little bit. So, we'll have a look at bees for a moment. So you have male bee and female bee. Yes? Now, what's interesting about bees is these two, well, I guess it's kind of interesting. These two together produce only female. So when the egg is fertilized, it produces a female bee. However, you can actually have just a female bee lay an egg, and when she does, it produces only a male. So it's not like with people, okay? So obviously mother and father can produce both boy and girl, but with bees, mother and father produces only female. Whereas unfertilized produces only male. Okay? Now that's interesting because if you imagine what happens previous generations, okay? Let's imagine here you had a male bee. Did it have a mother and a father, or just one? Just the mother. Okay, so above here is female. Right, what's above female? Male and female. What's above male here? Female only, and above female? Male and female. So this is like the family tree going backwards in time. Let's do one more. So above female is male and female. Above male is only female, and here is male and female. So this is 1. This level has 1. This one has 2. This one has 3. This one has 5. It's the same sequence that I just gave you a moment ago. So this sequence, actually, you see it in nature quite a bit. And here's one example of it when you're looking at the generations of a male bee descending back in time. Okay, so this sequence is actually called a Fibonacci sequence, if you've heard of that before. You've heard of this one, yeah. Yeah, this is an example of it. Huh?
I don't know. I think it's in sunflowers.
It's also in sunflowers and other stuff as well. I can't remember right now. Yeah. If you look up Fibonacci or golden ratio, you can find stuff online. But I just thought that was an interesting biology example of a sequence. Okay. All right. We'll wrap it up there. So I'll close this. Yeah.